So some test-inspired warm-ups to start us off. Try those two. I'll come back and show the answer in a minute, and then there's one more after that. So if you're watching at home, press the pause video, press the pause button, and give those a try. First one's a U substitution problem. Second one is average value, which means integration, but also some algebra in there as well. So there's some hints to get you started. Secant tangent is secant. Like, you know the derivative of secant is secant tangent. So you know that this antiderivative can take care of the secant tangent. So you don't need to do a U substitution on the trig functions, on this one, because the integral will handle that. But the 3's and the 6's are kind of a mess. So let's let U be 3x. du needs to be 3 dx. And now there's a couple ways to handle this. And I saw people do it both ways. You can just take the 6 out to start with, so you don't have to worry about it, and then put a 3 and a 1/3, a 3 inside and 1/3 out front. That works. Or you can say, well, I can just fix the 6 to make it a 3. I don't know which ones happen more often or which one you're more comfortable with. Method 2. It's like, I need a 3 there, so why don't I just multiply this by a half? That will make it a 3. Or, whoops. And then I'll put a 2 out front. So the 2 and the 1/2 cancel each other out. And again, the reason we did this is now this is 3 dx, which is du. And so we've got 2 antiderivative of secant of u, tangent of u, du. The antiderivative of secant tangent is secant. So 2 secant of u plus c. And then don't forget to plug u back in. 2 secant of 3x plus c. Again, both of these very much test inspired. Number 2 is sort of a combination of 2 questions from the test. 2 birds, 1 stone. 2 test problems covered by 1 warm-up. Average value. Generally speaking, 1 over the width times the area under the curve. So 1 over 3 minus 1. The integral from 1 to 3. X to the 5th minus 3 over x cubed dx. Okay, that probably gets you half credit on that question, because that shows you knew the calculus, you knew how to set it up, or at least you knew some of the calculus. Now we need to integrate. So 1 over 2, integral from 1 to 3. I'm going to divide both of them by x cubed and rewrite the second one as an exponent so that I can take its antiderivative. So x cubed over 3 for that one, minus 3 times, let's see, increase the power by 1. So negative 3 plus 1 is negative 2, and then divide by the new power. Now we're really close to a safe stop here, but this isn't a safe stop because I've still got calculus stuff here. This isn't calculator ready, so I need to plug in the top and plug in the bottom. Do I want to clean this up a little bit first? Maybe, maybe not. The 2 negatives make a positive, and then I'm going to put that x squared in the bottom. I guess I don't have to do that. So 1/2. Plug in 3, I get 27 thirds plus 3 over 9. Both of those reduce, but we're not in the reducing game. We're in the calculus world, so leave it alone. Uh-oh, did I mess up?
What happened at the bottom? The 2 denominator.
Oh, thank you, the 2. the 2 denominator. And that's the nice thing about safe stops. If you catch your mistake, it's easy to fix it. I'll just stick a 2 down there and we're good.
I have something that's like very, very similar, but I didn't do as much.
Hold on, let me finish and then I can look at yours. So plug in 3, plug in 1, so that'd be 1/3 plus 3/2. And yeah, all sorts of reducing and fractions and whatever, but no thanks. Safe stop. There's my average value. Which means, yes, your answer could look a little different than mine if you wrote things differently, if you did some reducing, depending on how far you took it. Andrew, you feel okay about your answer? Or?
Well, no, because I didn't simplify it as much.
You left it as like right in here?
No, I like plugged it in different, because I didn't like.
Can I show it on the screen?
I don't care.
Okay. Make it a learning experience for all here.
I just didn't plug it in. Sorry, I plugged it in, but I didn't.
So x cubed over 3. 3/2 x to the negative 2 with a plus. That's good. 1/3 3 cubed plus 3/2 3 to the negative 2 minus. Yeah, I think this is fine. One minor thing I would say is that the way you have it written, this coefficient out front is only going to this.
Okay.
But that's it.
Okay.
Other than that, you're good. Warm-up number 3. Calculator. This is a no calculator question, which is why it says write an expression. The test is going to say, but do not solve, meaning it's going to be ugly and you're going to wish you had a calculator, but once you set it up, you're done. Snow melts at a rate. Rate is underlined. I think on the test I italicized it to sort of draw your attention to it. Hey, this is a rate. Write an expression for how much snow is left after 4 hours. If there are initially 13 inches of snow. So if I have the rate that it's melting, how can I get how much is melted? If I have the rate, what should I do to sort of go backwards to the amount? Integrate it, because rate is a derivative. So if I integrate the rate from time 1 to time 2, I get the amount at 2 minus the amount at 1. Very roughly speaking there. That's the first fundamental theorem of calculus. The antiderivative of the derivative gets you back to the original. So the melted snow, or how much is melted, would be the integral from what to what?
0 to 4.
0 to 4 of the rate. So I'm just going to put the rate in there. Pi over 6 sine pi t over 12 dt. Who knows what that is? Who cares? It's a calculator problem. So that's how much is melted in 4 hours. But I want for how much is left if there were initially 13 inches. So what should I do? I started with 13. That's how much is melted. Subtract. So the snow after 4 hours would be 13 minus. And if we called this a variable, we could just use that variable. M is already used. I'll just write it all in again. But even on the AP test in the free response section, you're welcome to introduce new variables if it sort of makes things easier. Like you want to use this expression several times, so I'm just going to call it A. And then if you'll define it as A, you can use A the rest of that problem, and the grader will know what you're talking about. So again, test inspired. couple things that are mirrored from the test. The integral of a rate is an amount. It also models the fact that it's a set it up but do not solve problem. So this would be a calculator problem, like you just type all that in the calculator and get an answer. So there's I think 2 on the test where the answer looks not exactly like that, but something with an integral in it. That's an ugly integral, and that's why it's a set up but do not solve problem. And you just leave it. That's your answer. If you had a calculator, you could type it all in and get an answer.